Hi, good afternoon, ladies and gentlemen. In very short notice, we have invited a lot of people for today's webinar, March 6th, 2026 at 4 p.m. We are conducting a webinar on fire resistant coating system for structural steel and also HVAC duct. You can see handsome man, next gen, Aditya Sibal, with us today, who will be presenting this detailed presentation on the subject that we have covered. Why this is important? So I'm again a warm greeting to all the architect friends today, fire engineer, consultant, developer, especially EPC contractor. And we have fantastic gathering today from all across the country. Our webinar has been, last year, when I say last year up to December, we touched upon 73,000 people through various webinars that we conducted last year. So this year we are intent to cross 1 lakh because most of the Friday and Saturday we have various subjects that we are talking. Tomorrow we are talking about missing link in building. There is a huge missing link in building that we are doing tomorrow at 11 a.m. So Blue and Gray consultant has been encouraging companies, encouraging experts to come and do a presentation where our audience of more than 150,000 who are there, who are subscribed to our various topic can take this webinar seriously and also practice in their day-to-day profession. So today our knowledge partner is Amitav, very well-known company. I know Mr. Ashok Sibal, who is also there, a fantastic human being and a great researcher. And I'm very proud to say, as an Indian, he is doing a noble cause by introducing the fire resistant, fire retardant coating to protect the structure, structural interiors and all that. And these are very local. The Indian, make in India, and his product is at par with any global standard companies. So I warmly welcome all of you today. An important webinar on fire resist coating system and structural steel building and HVAC duct. So fire safety in modern buildings is no longer only about detection and suppression. Generally when we say fire safety, everybody thinks about fire detector, everybody talk about firefighting, sprinkler, hydrant system. Nowadays, since last 1 year, increasingly passive fire protection system are becoming the backbone of resilient building design. So let me begin with simple but critical fact. I'm sure everybody is aware, when the steel is exposed to temperature around 550 degrees Celsius, structural steel can lose up to 50% of load bearing strength. And around 600 to 650 degrees, the steel can almost lose 2/3 of its structural integrity or structural capacity. This means that during fire, unprotected steel structure can begin deform, buckle or collapse within the minute. If you've seen many of the showrooms, many of the building of 5-10 floor, today they come up within 3 months, the entire structure comes up. So every day the technology, people are now using steel structure to complete the project. Many of you, I'm from Bangalore, I could see many of them are using steel structure for up to 5 to 10 floors. But when I read out these statistics or the facts, the fire resistance coating play an important vital role. These coatings create a thermal barrier that delay heat transfer, allowing the structure to maintain integrity long enough for evacuation and firefighting operation. Another area we often underestimate is HVAC duct system. In many large buildings, malls, hospitals, airports, and commercial complexes, duct network can unintentionally become pathway of fire and smoke spread if not properly protected. If not properly protected. You have seen, most of the fire doesn't kill anyone. It is the smoke that kills everybody. The recent one in India is the Goa. There was only one exit, narrow exit, party hall. Even now, if you look at many discotheque here, they have only one exit. They are steel structured and they have the shelter made of fabrics and all that. Very surprising that none of them taking still now, even after Goa incident, no one is taking seriously to protect these structures. Globally, many fire investigation. We do a lot of, I'm a fire auditor. I keep doing a lot of investigations from high-rise incident to industrial fire. We have shown that structural collapse, smoke spread often occur because passive fire protection was inadequate or improperly installed. I repeatedly say improperly installed. As India continue to construct taller buildings, large infrastructure, airports, metro stations, data centers, industry facility, the importance of fire resistant coating and passive fire protection system becomes even more critical. So in today's webinar, my friend Aditya will try and address the very gap, that is the science behind the fire resistant coating, how structural steel can be protected during fire exposure, protection strategies for HVAC ducts, compliance with fire safety codes and performance standards, and practical solution being implemented in some of India's most critical infrastructure by Amitav. Our today's objective is very simple: to strengthen the awareness, design understanding, and correct implementation of passive fire protection system in modern building. Let me tell you, this passive fire system is invisible. Other than the fire door that you see, with they claim the 2 hours rating, your gypsum board, flooring, your roofing, steel structure, you cannot identify whether it is protected or not. In lot of people today, they claim that it is a fire resistant. There are a lot of duplicates. A lot of people compromise on that. So nobody is aware. Today I am more interested to see if someone buy 1 kg of paint. How will you ensure that quality is maintained by the contractor? You buy a paint, you add 10 liter more water into that. It doesn't achieve the result, achieve whatever we are talking today. I'm also quite keen to know how this can be avoided. So, I'm confident today's session will provide valuable insights to everyone in design, engineering, construction, safety, management of building. I request all the participants to put your question only in Q&A box. Don't put it on chat box because it will not go on recording. If you look at scroll down, there is a Q&A box. Please enter your questions, any queries that our speaker can pick up and talk. And myself, Dominic, I'm founder of FSA, Fire and Securitization of India, Focus, Forum of Construction Utility Services, NFE. Today we are celebrating 3rd year birthday of NFE, National Federation for Electrical Safety, and the one which is coming a big moment in India, Council of Fire and Life Safety Professionals, CFLS. This is the association going to change the landscape of our safety professionals. So I'm so proud that, being the architect of many of these associations. And as I keep saying, knowledge is not to keep forever, the knowledge is to spread. Now, unless you don't give back to society, purpose of life is waste. So I have the young and the future of the fire protection is Aditya Sibal, the young man, So Aditya leads an institutional partnership of Itum, a brand with over 35 years of expertise. Amitav is a well-known. I don't need to talk more about it, and they're protecting almost all the critical. Look at the new parliament, new secretariat, prime minister office, and Supreme Court, Bangalore Airport. The name the important tunnels, metros, DMRC, Delhi Metro Rail, the most of the structures and all protected by Amitav. So I'm happy that today Amitav is taking up and the presenting, and Aditya Sibyl is going to do the presentation today. So I'm going to unshare this now, and I'm going to call Aditya, who's this is our second time we are doing a webinar with you, Aditya. And last
Yes,
time we
sir.
had a very interesting conversation with people, and you are becoming a well-known face now in the fire-resistant coating. And I'm sure as day goes, as month goes, Aditya is like Sachin Tendulkar in fire coating. Mm? So I welcome you, and I'm also welcome Senior Sybil, also there silently, watching from behind the screen. I'm sure he will come during the question answer. Over to you, Aditya. Welcome back.
Thank you so much for the kind introduction, sir. So, sir, today's objective is really simple. It's about creating awareness about the fire-resistant coatings dependent on structure, steel, and HVAC ducts because people think it's just about compliance, but it's really much more about it. I'm very recent in this field, 2 years maybe, but I've learned a lot about it by meeting you, by meeting various people, and also talking with my father. It's really crucial that we put right amount of coating, right type of coating to the right type of surface. So for that only we are here to present the. I made a PPT for this webinar, so I'll just share that.
Okay, go ahead.
Is it visible, sir?
Not it. Yeah, now it's okay. You can go full screen.
Second. Yes, sir. So the
Good.
topics today we'll cover are the obviously the introduction about a company, and then why fire resistant coatings are mandatory for structure, steel, and HVAC ducts by authorities such as NBC and NFPA, and how the fire resistant coatings actually work, how they protect the steel and duct systems during exposure, the technical advantages of the new type of coating such as silicone epoxy coating in fire protection applications, along with case studies to support the claims, and the recommended fire protection solution by us that we believe is the best and have successfully executed in multiple projects. And lastly, the testing standards, system design, and on-site preparations for all the consultants to note down. So, firstly, about Amtov Technical, we are a 36-year-old manufacturing wide range of fire resistant and fire retardant coatings for multiple substances, including structure steel, ducts, cables, wood, fabric, other coatings as well, specialized dielectric, RFID shielding, marine paints, anti-fouling, and many more. That gives us a deeper knowledge about the surface or the application process across all sectors. And then we have a dedicated R&D formulation, which we operate in two different centers where we do not simply follow the global formulation, but engineer technologies suited for the real project conditions in India. Since we believe that India's environment is different than the foreign environment and the coating durability should be more. And we are trusted in critical infrastructure projects, as you just said, in the new Parliament building, Palam Airport, Central Vista, Central Street Secretariat buildings, and be it airports, Prayagraj Airport, Guwahati Airport, all are done by us. And then national and international testing, amateur products are tested as per major fire testing standard, including BS 476, Part 20, 21, 22, 24, and then EN 1366, ASTME 119, and UL 263. And that too from NABL and ILAC MRA accredited labs. These are just some names of our recent projects: Seabird, High Court, Supreme Court, Konkan Railway Corridors, then data centers, Amazon data center, Microsoft data center, and Foxconn Apple project, where Apple has successfully planted their plant for iPhones, and even refineries where hydrocarbon fire scenarios can happen. We have prepared for our coatings for that too. These are some major approvals we have from CPWD, Konkan Railway, Aircon, MES, Dial, AI, Jaber Airport, Indian Oil, Bridge and Roof, and DMRC. Moving on to the subject about this webinar, why are actually coatings necessary on structure steel? So, as you just said, that steel loses its strength about at 550 degrees Celsius, and the fire temperatures given help with the synthetic material which is commonly used in new buildings can reach up to 800 to 1000 degree within minutes. So you can imagine how quickly the steel will start bending. And then the coating helps maintain integrity and buys the evacuation time by protecting the steel to 2 to 4 hours. So that time the safe evacuation can happen, and the rescue and emergency team can actually help people and evacuate the building. And these coatings just not only protect the metal from fire, but they also have anti-corrosive properties as well as anti-carbonation properties. Meaning they not only protect the fire, but they also won't let the steel catch rust, or they'll try to prevent aging as much as possible to extend the lifespan of the steel structure. These coatings also comply with codes which made mandatory at the NFPA and BIS and NBC as well. And then they also minimize property loss by preserving structural integrity. Coating rules protect valuable assets and reduce damage, and most importantly, lives. And cost-effective risk management, if we see the cost, the fire coatings are a small investment compared to the potential cost of rebuilding or loss of life. That really means something because people try and get away with it, but when the building actually catches on fire, it's a huge mess. Here I have attached an image where it shows the bending of steel and the protection of intumescent coating and how the coating expands and protects the metal. I'll dig deep more about it in the end. Other than that, we'll come to the essential reasons to apply fire-resistant coating on duct as well, since we are talking about HVAC ducts as well. So the first reason will be prevent fire spread through ductwork, because as you said, ductwork can unintentionally act as pathways for fire to spread, and they will spread the heat rapidly and the fire. And fire-resistant coatings create a protective barrier that slows or stops this spread. Then they also maintain smoke extraction capabilities in crucial time like these. Since you can see in the image, the smoke buildups faster than the fire, and smoke inhalation is the leading cause of fire-related deaths, not the fire. Coatings help duct retain structural integrity at high temperature, ensures that smoke can be effectively pushed out of the building, so that people can see the fire exit or actually ask for help. And the coatings preserve the structural integrity of the ducts under extreme heat. The ducts may untrap or melt or collapse. They can block the fire exit, or they can hurt somebody. Fire coating insulates the duct surface and maintains the shape function. And compartmentalization and containment, that's really important. Coated ducts prevent fire and smoke hot gases from leaking through joints or penetration, supporting passive fire protection, meaning that if a fire happens in one room, it won't let the fire carry on to the next one. Here's an image for that: coated and insulated steel duct working properly and extracting smoke, and the fire is not spreading out of that room. Then fifth, it also provides critical time for evacuation and firefighting by delaying the fire spread. Coatings buy valuable time. And then they also protect vital systems in sensitive zones, such as in hospital, data center control rooms. Maintaining ventilation and preventing fire ingress through ducts is crucial. And they also comply with fire safety regulations, same as structure steel. Coating ducts is mandatory under building fire codes such as NFPA, NBC, IBC. And they also help ensure building-wise fire safety certification and insurance coverage. And lastly, these coatings come with a fire sealant to seal the gaps, cracks, or joint. Many fires exploit the small vulnerabilities. Coatings seal these weak points and adding a continuous fire resistant layer. Moving on, we'll come to the types of coating available in the market. So there's intumescent coating, ablative coating, and a vermiculite coating. And I'll discuss about how their mechanism works. So in an intumescent coating, a fire intumescent coating expands under high heat to form an insulating barrier that slows and prevents the flame spread and creates an insulating char. That intumescent expands up to 50 times the original size, but sometimes maybe even 70. Then we come to an ablative coating. This ablative coating doesn't swell like intumescent. It protects the surface by slowly charring and eroding under high heat, absorbing the thermal energy and preventing flame spread. It is commonly used in fire barrier ducts and aerospace applications for heat resistance and safety. And then lastly, we come to the vermiculite coating, where it's a fire resistant material that insulates seals, steel, and concrete against high temperature. While effective, it requires a thicker application and may affect aesthetic and add a lot of dead load due to its high DFT. For further explanation, I've done a technical comparison for all these type of coatings. As fire performance in test furnace does not automatically translate into reliable performance on sites, over decades of service life, real world exposure conditions, the application is variable and the material behavior can change. The following are the technical factors critically test the reliability and the long term effectiveness of the fire protection system. Here's the list, and I'll just cover some very quickly. So there's anti-corrosive protection, charge stability. We'll dig deep more in the. So firstly, we come on the charge stability under fire exposure. As I just said, intumescent coatings have a tendency to expand up to 50 to 70 times more. So if the char only falls off under fire exposure, then the steel is exposed to fire, and steel is conductive in nature. So even if you lose a patch of that char, it will conduct the heat through all the framework, and the point of doing that coating will fail. So here I have made in comparison with the nature of fire barrier and char cohesion at 900 to 1050. I have attached a case study as well, where it is found that fire resistant coatings with certain different type of fillers can improve the char formation and thermal stability during fire. With the char, they are reducing heat release and maintaining lower backside temperature under prolonged use. Where we notice silicon epoxy system has a reinforced stable char. As we know, ceramic reinforced stable char means it will stick to the surface no matter what. Water base also has an organic intumescent char. Vermiculite is just a thick coating and it does not require a char. It is an inherent mineral layer. Then char cohesion, it remains high. Then water base has been tested to see that moderate or it can be prone to cracking and shrinking. And vermiculite, same, no char. Then resistance to flame erosion. That is, sometimes the fire develops a certain PSI. So the char should be able to handle that too. So the silicon epoxy can easily resist that PSI and water base as well. Where vermiculite is a brittle coating, so sometimes surface piling is noticeable. Then char adhesion to the substrate means the bonding capacity. That is, silicon epoxy has a strong water base, can lose its strength, and vermiculite has no bonding mechanism. Post fire residual protection means after the fire, what's left. So silicon epoxy sticks to the surface, whatever's left of it, and water base mostly collapses, and vermiculite as well, brittle and cracks or spalls. Moving on to the bigger point, that is corrosion under fireproofing. This is a real concern in our fire safety world, actually, and also in India, since we forget that the coating is done, and that can have a disadvantage as well, that you won't be able to see the corrosion happening under it. So to declare that, I have attached a case study as well in an offshore unit. A field study on an offshore unit documented corrosion beneath passive fire protection caused by moisture ingress through cracks in fireproofing, corroding steel anchors, mesh behind layers. The damage progressed hidden, leading to loss of adhesion, cracking, and local detachment of fireproofing, exposing steel members. This directly compromise the integrity of fire barriers and the mechanical stability of the protective structural elements. Here I've made a comparison as well. So silicon epoxy is inherently anti-corrosive in nature due to silicon versus epoxy. And then water-based systems are primer dependent and don't have a inherent anti-corrosive property, where vermiculite is a porous cementitious layer, so does not offer any anti-corrosive properties. And the barrier against moisture and oxygen. The silicon epoxy almost creates a plastic-like layer which is dense and cannot be penetrated, while water-based systems are totally dependent on the primer and are hygroscopic in nature, so they attract water, and vermiculite as well. They are hydroscopic in nature and they allow water to enter. Compatibility with anti-corrosive primers. Silicon epoxy does not require any primer. It can be directly put on the surface after surface preparation. Any surface before coating requires surface preparation, that is rust, dust, oil free. And water-based system requires a different primer. Vermiculite requires a separate primer. And the risk of corrosion, as said, in silicon epoxy is low to none. Water-based can happen. Vermiculite coating is bound to happen. It's just a matter of time. And then long-term steel protection is higher in silicon epoxy due to its inherent anti-carbonation properties. And water-based systems have a limited long-term steel protection, but they work fine. And vermiculite does not have a long-term steel protection. It requires maintenance after maximum 10 years. Moving on, the next point would be the bond integrity during a fire. So as I said in earlier, bond integrity during and before fire is really crucial. If the bond is only not there, the coating won't perform and will leave a patch of steel exposed to fire that can conduct it to the whole framework. I've attached a case study on addition behavior between intumescent coating and steel substrates. Shows that effective bonding mechanism depends wetting ability, surface tension, and mechanical interlocking, factors that directly affect post-fire addition strength. Here I have listed few standards which are tested by us in silicon epoxy and water-based and vermiculite, where we observed that according to ASTM E736, a bond strength for fireproofing, silicon epoxy passes the long-term addition retained, while water-based also passes with the addition degrading over time, and vermiculite also passes that test, but only till the laboratory. Moving on, we'll go with the ASTM D2794, an impact resistant test, where silicon epoxy had no deformation upon impact, while water-based has a local chipping and deformation, and vermiculite coating fails that test on the impact. ASTM E760, that is bond addition performance. Silicon epoxy passes long life with a long life addition. Water-based also passes that test, and the vermiculite complies on the lab. Then post-fire addition is the after furnace exposure. The silicon epoxy, as earlier we discussed, the bond retained to the steel, and water-based has a partial chipping off, and vermiculite coating simply peel off. Then we shall move on to the vibration resistance. So here I have attached the case study for this as well. A published experimental study reported that cementitious fireproofing on steel loses bond and develops cracking under service-induced deformation and repeated loading, leading to partial detachment of fireproofing layer. So what that means is that we have tested this via creating a cyclic motion again and again to replicate the vibration made in a building over years. So that where we observed that strain accommodation, silicon epoxy had no effect over time. Water-based over time may require maintenance, and vermiculite little to none peel off over time will happen. And a fatigue response under cyclic loading, then that means that multiple loads are being done. So silicon epoxy has no crack initiated over the repeated cycles. Water-based micro cracks were seen, and vermiculite started cracking in the early stages. Then we'll move on with the crack probation rate, low, moderate, high, bond stability under vibration, a stable interface, no progressive debonding, progressive weakening, loss of mechanical strength, damage after cycles. We saw no damage to silicon epoxy system, and water-based intumescent had local edge cracking, which can be easily done via local patchwork, and vermiculite coatings had peel off. Water resistance is also a really crucial factor when you are going for a fireproofing on steel substrate, where test standards are made according to ASTM B117. That's a salt spray test where corrosion or moisture exposure is studied. In silicon epoxy, it passes that test. Water base also passes that test, but vermiculite coating fails that test due to the moisture ingress and the porous nature, allowing the water to enter. And then ASTM D2247, humidity resistance, important for application in coastal areas. The silicon epoxy system passes with no problem, and water-based intumescent coating passes with softening or bristling over cycles, and the vermiculite coating also fails in this subject. Then ASTM D870, water immersion, where you dip the sample in the water, and silicon epoxy had no effect. It passes the test. Water base also fails that test, as well as vermiculite. And ASTM D570, water absorption. Silicon epoxy did not absorb any water, negligible, and water base did fail that test, and as well as vermiculite. Then ISO 11130, water resistant. So silicon epoxy passes the test. Water based also passed this test, but vermiculite fails this test due to its porous matrix. IS 101, water resistance or durability of the coating. Silicon epoxy passes and are durable under immersion and humidity. Water based passes but with a reduced durability, and vermiculite fails with a significant loss of coatings. Coming on to a very crucial factor about hygroscopic behavior. So we have attached two case studies for this as to prove how vermiculite coating are hygroscopic in nature, meaning they attract water, which is really bad for steel as it will invite corrosion. So vermiculite is a hydrous porous mineral, so it naturally absorbs water and holds moisture within its structure. When vermiculite is mixed with the cement to form fireproofing, the resulting coating becomes the moisture absorbing matrix by material design, not by application defect. This porous microstructure allows the water to enter and remain within the fireproofing layer rather than shedding it. Retained moisture stays in contact with the steel, increasing the risk of hidden corrosion and gradually loss of fire protection integrity over time. As you can see in the attached mirror image, vermiculite coatings are thick, so you don't see the corrosion happening under it. Then when it peels off or you peel off by external damage, you can see the corrosion. In the same way, the performance in coastal, damp, and seepage-prone areas, as everyone must be aware of what type of coatings they should be using at different types of location. And if you are using coatings in coastal, damp, or seepage-prone areas, you should always go with an epoxy system, which is silicone epoxy system. Water-based paints or vermiculite won't sustain in that environment. As seen on the left on the images, I have attached the same case study as before for the offshore unit to show the water-based coatings peeling off and exposing the steel to fire. Then the dead load DFT difference. This factor is also overlooked many times, but so basically the three types of coating, the silicone epoxy requires the average DFT of 1500 microns. Considering we want a protection of 2 hours on a 6 mm plate. And on the same hand, water-based coating will require a 2 mm thick coating to protect it from 2 hours at a 6 mm plate. But vermiculite coating will have a microns of 25,000, that is 25 mm for a 6 mm plate for 2 hours of fire protection. This is a concerning factor because this is just not an increase of application process or application time, but it also adds a significant amount of dead load. So I've attached a case study where research confirms that the increasing fireproofing thickness reduces heat transfer to steel and extends the time taken for members to reach critical temperatures during fire exposure. However, the thicker fireproofing systems inherently add more permanent mass to steel elements, which must be accounted for as a dead load in structural design. This additional mass influences member sizing, connection designs, and load combinations, particularly in long span structures. Therefore, fireproofing thickness selection affects not only fire performance but also structural response and design margin. And I have made a comparison on it as well. Thickness category, thin film, thick buildup, and exposure to external forces. Imagine if your coating is only more thick, it will be prone to external damages, so it can peel off easily, and the risk of cracking in a thick coating is much higher than a thin coating. There are some other reasons as well, other factors where controlled DFT achievable, that is quality check ease. So silicon epoxy can be checked easily with an alcometer, same as water-based, but vermiculite coatings are so thick, they have to be checked differently. Silicon epoxy offers fast drying time, improving the application time taken and helping the project get completed sooner. And same as water-based coatings, drying varies with the humidity and site conditions. Cement coatings are usually uh, difficult to apply and takes time and are not easily applied and are quite messy. Surface hardness and impact resistance as per IS 101, ASTM D3363, ASTM D2794. So we have done the test, we have passed the test with silicon epoxy, we have passed the test with water-based system, but we had failed with the vermiculite system. Since we are a manufacturing company, we manufacture all types of coating and have got it tested from various labs to come out to with this result. And moving on, we'll go to the flexibility and bend test compliance, which follows the standard of ISO 151, 9B571, and IS 101. So where we noticed the silicon epoxy system accommodates steel movements without cracking, and water-based also accommodates limited strain cracks under high force, but vermiculite coatings does not pass the bend test at all. And then we'll have on more factors such as ease of local repair, localized spot repair feasible without system removal for silicon epoxy. Water-based system is a little bit tougher than silicon epoxy, I can say, because the patch repair not possible without the full peel off of the local zone. And cementitious coatings patch repairs are very difficult and messy again. Moving on to the physical appearance about how the coating looks, as steel structures are used inside the buildings to show as an aesthetic as well. So the silicon epoxy and water base offer a generally smooth finish depending on the top coat of the customer's choice. And then vermiculite coatings offer a rough porous surface, and also dust accumulation can happen over time. Then color retention, that is judged by UV resistance at ASTM G154, where the silicon epoxy passes the test, and but the UV resistance test can be in water-based can be seen to chalking or local peeling off, and vermiculite has no color stability. Air erosion as per ASTM E859, in silicon epoxy it passes the airflow erosion test as well as with water-based. The vermiculite coating does not. It creates as a dust form of coating and does not pass the air erosion test. Then fungal microbial growth resistance, that is also important in coastal areas. If you can see ASTM G21, that is an inorganic polymer matrix for silicon epoxy, does not support fungal growth, and water-based organic binder system, fungal growth possible in humid zones, and vermiculite coating porous cementitious matrix retains moisture, fungal growth possible on the steel. And then lastly, we'll come on to the acid and mild chemical resistance. Silicone epoxy also offers mild chemical and acid resistant properties, while both coating does not. So that's about the technical comparison between the all types of coating available in the market. What we believe is the best is silicone epoxy, then on the water base, then vermiculite. As vermiculite is an sort of obsolete technology as it's been running from the British times. Now we have developed new solutions, new formulations, thinner coatings. So we believe that these should be adopted and have created and started created a more awareness about it for people to go for better solutions. So at Amitav, the recommended system for ducts, what we suggest is firstly, of course, the surface preparation. Prior to any coating application, the surface must be thoroughly clean and using we also offer the 3-in-1 chemical. This ensures optimal gripping of the coating to duct surface. Then we go on to the base coat. That's an when the surface is free from rust, dust, or other any other contaminants, the primer has fully dried. We apply our ARC265SC, that is a silicone epoxy based coating, and that coatings offer excellent adhesion, fire resistance, provides anti-corrosion properties and antifungal properties for long-lasting durabilities. Then over that, we apply an water-based coat, that is an ARC265WB, a water-based top coat to ensure compliance with the VOC regulations while enhancing the cost efficiency of the overall coating system. Since cost is a very big factor in India, we aim for providing the best fire protection solution at the best cost as well. All our coatings are very economical. It's not that the silicone epoxy coating is very expensive than the other two. They all fall into the similar price range. That is our objective, to make people go for better and modern solution, but don't let them compromise on the cost. So we go for a water-based coating as a top coat to protect the structure from anti-carbonation properties as well as VOC regulations, which are very important, and the green building norms. Then we do a top coat over that. That is optional. With that second coat done, the water-based coat done, now your duct is now fully protected from fire in accordance to BS 476 Part 24. To ensure system's durability, we apply an anti-carbonation top coat which slows the aging process of the coating. This coating also gives a similar smooth finish, uniform finish across all ducts. And lastly, upon installation of the duct, to prevent any gaps between duct joints that can allow fire to spread inside, we apply our ARC244 duct joint sealant along with ARC317 fire resistant gasket. That both products enhance fire safety and help maintain consistent air pressure within the duct system. And we have a similar system for structure steel as well. After surface preparation, the primer layer of silicone epoxy primer, once the surface is rust, dust, and oil free, Amituf recommends a thin primer coat of ARC250PR, a silicone epoxy fire resistant zinc phosphate primer that that provides anti-corrosive properties, prevents surface damage, and ensures high compatibility with fire resistant top coats. Moving on, we'll go with an intermediate coat. Once the primer is fully dry, we apply multiple coats of our main protection, that is silicone epoxy fire resistant ceramic coating, ARC254. This coating almost covers 3/4 of the total DFT system. Top coat, a water-based plain finish again for the VOC norms for green building compliance. After the ARC254 fully cures, we apply ARC253PP, a water-based fire-resistant top coat for a smooth uniform finish and added protection. And an optional second top coat can be the same of anti-carbonation coating to prevent it from aging and fungal formation. Whenever you are going out to buy a fire-resistant coating for any type of project, you must know about the certifications and the importance of certification in the market. That's why at Amita we have gotten our products tested from Government of India lab, that is National Test House, State Government lab from Haryana, CBI Roorkee, that's the best lab in India for fire testing, and multiple NABL accredited labs. And we have our ducts tested internationally at Effective International Lab, and many other world-class labs such as Spectro, Bytes, for which I have attached the test report for just for your reference for you to see. We have the test certification for silicon epoxy via National Test House. We have certification for our recommended system, that is ARC 254 as a base coat and water base as a top coat for 3 hours from Spectro Lab, which is an NABL accredited lab. Then we have a test certificate for a load bearing structure for 3 hours with the same solution of 5453 and an anti-carbonation coating. Even that lab was accredited and is accredited by ILAC MRA, that is an international accrediting body, and NABL as well. This is a report from test report from government Haryana State Government Lab for as silicon epoxy as base coat and top coat. We have a certification as well from CBRI Roorkee. I'm just showing this for the reference. We can, of course, if anybody wants to deal with us, we can connect on mail. Multiple test reports are done according to multiple standards for compliance at various projects. Then we have a test report from National as well for 4 hours. A test report for 2 hours. So lastly, we'll be talking about the on-site execution and compliance. So I've divided into 3 stages. So stage 1 would be the surface preparation and pre-application inspection. So whenever you are going with a company for fire resistant coating, you must normally give it with material job. So it is very important for you to check the surface cleaning, degreasing or blasting as required to remove rust, oil, dust and any containments, and the verification of surface condition and dryness before coating application. Because if the coating is not clean, the steel is not clean, the coating won't perform, and then there will be a big confusion whether the problem is within the coating or the site execution. So it's really important to check the surface for better coating performance. Second stage would be the coating application and thickness control. So the application of compatible anti-corrosive primer and fire-resistant coating system should be there. Uniform coating application using brush, roller spray, depending on site condition, and monitoring and verification of a dry film thickness DFT to achieve the specified fire rating. I've attached an image for an alcometer on the right side. This is how you check the DFT of a coating. Here, as you can see, is checking the coating and it is coming 170 microns. On steel, we say the thickness should be above 1500 microns if it's a 6 mm plate, or in ducts, we recommend 700 to 900 microns. And then the stage 3 would be the final inspection and site compliance. So visual inspection of the coating integrity and surface finish. You can scratch it, you can check the hardness, you can check the impact, you can do the salt spray test. There are multiple tests that can be done after the coating is done. Then of course the DFT measurement for documentation, for quality assurance, and ensure that proper curing before the commissioning to ensure the full fire protection system. That means give each layer of coating time to fully dry. Don't put the coating on a wet surface. The coating will peel off and there will be a lot of confusion. I think that's it from my side regarding the fire resistant coating for structure steel and HVAC ducts. I hope everyone got a bit of an idea what I was trying to convey.
Hi Aditya, we have seven questions. Okay.
Yes, ma'am.
So can I take the questions, or you want to take whichever questions you want to?
Me and father are both there. We'll take each. No problem.
So can I read the questions, or you can also see the
So,
questions? How is
Vijesh
it?
Shiraj, I have read, I think. These are the questions, right?
Yeah, right.
Okay, okay. So, what coating do you carried out on ducting? Two, do you have test evidence on PS 476 Part 24 respect to coating? Three, what is the testing temperature? Four, details of stability, integrity, installation. So, I'll answer this one by one, I guess. So what coating do you carried out on ducting? So we, as I said, we carried out a multiple coating system of one being silicone epoxy, the second being a water-based coating. Three, do you have test evidence on BS476 Part 24? Yes, as I showed you the test reports earlier. Three, what is the testing temperatures? We test above 1100 degrees Celsius. With insulation for ducts, with insulation, we go for 1100 degrees Celsius. And without insulation, we go for 300 degrees Celsius. As that's the smoke temperature, and we have to make sure that the smoke does not melt the ducts. For details of stability, integrity, and insulation criteria based on the testicle results that is mentioned in test reports that you can ask for us on our mail. Then four, considering material loses strength in high temperature, that I don't understand. Four, how do you calculate bearer or drop rods have been calculated. So while doing a structure steel building application, we have an HP oblique A ratio, heat parameter upon area of cross section, where we calculate the steel thickness, and we via that we evaluate how much microns would be required for it to be protected to the required fire rating. That could be 1 hour, 2 hour, 3 hour, 4 hours. I think that answer your question, Mr. Gijesh Shiraj.
And the
Yeah.
next question from Saurabh.
Yes, ma'am. So does kitchen exhaust MS duct need to have mineral wool as insulation to comply to our fire rating? It
Yes.
can have, yes, as Mr. Ashok Sibbal said.
Yeah.
Okay, then Ankesh, in that slide about char stability, does the application depend on the profile, shape of the base material on any other primer pre-application? Also recommend that the cost of application should be defined dollars to understand the value proposal.
May I answer?
Yes, yes.
So in this slide, charge stability. Charge stability depend upon what type of primer you are using. If you are using fire-resistant primer uh, and on the pre-treated surface, whether sandblasting done properly, then it will remain on the surface. So the char and the thickness of char also matters, because what we have seen in the case studies, lot of cases where char falls. If the char fall down, then your structure is at risk. So I normally recommend ablative coatings. They, as in, if you buy 3M material or Hilti material, they are also ablative type of materials. Means char is there, but char thickness is too less, so the stability remain on the surface, and it gives you fire resistance for longer durations. I think I have given you answer for this question. Thank you. Actually, again, same the question. In the bond integrity side, what long terms means in years? It is 25-year plus if you are going with the silicone epoxy. And third question in vibration resistance. And yes, this is the main thing, because vibration, if you are using this vermiculite coating based systems, the vibration is the main concern, because if the coating thickness is more, chances of fall down is more. And if it is silicon epoxy base, it grips to the structure. That you can, lot of case studies are there, even in where earthquake happened, but the structure remain intact. This coating remain intact on the structures. So seismic rating, you cannot means normally 8.5 seismic rating. It can there will be no change in this bonding strength. And the water resistant salt spray, how much hours? Approximately 500 hours salt spray it will pass. My experience of the coating non-ferrous base such as copper and aluminiums. So I think you should write a mail. We will give you detailed reply on this. Next to Aditya. Yes.
Then Geronimo Farrow has asked, how long will the coating last to ensure its fire rating integrity in assumption of no fire and the system is always ready? So the coatings, such as we told that silicon epoxy is meant to last more than 25 years, and the water-based coatings can start peeling off after 10 years, and vermiculite coatings require maintenance after 5. That's our assumption, that's our testing, that's what we have seen. During terms and conditions, how can we prove its fire rating, or do we need to test it? Does the certification of supplier can suffice? Annex for conference report. So while buying a fire paint, I think the crucial factor is you check the lab they have gotten the test report with. You can cross check with the lab also that have they even got it tested or not, since sometimes people gather our certificates and make edits in them and claim that they have gotten it tested as well. So the best solution is to contact the lab as well for more cross checking about their test certification, and check the lab's credibility as well, such as I was telling that we have tested from NABL accredited lab, ILAC, MRA and accredited labs. Not all labs have these type of accreditations and can easily filter out the rest of the crowd. Third, can we have a fire rating comparison of steel or ducts between no coating versus fire rating coating? If you don't have coatings on steel or ducts and there's a fire, they will melt. For steel, they will melt at 550 degrees Celsius, and ducts are even thinner, so they will start melting way sooner than that. Do we have actual projects or references available in the past so that they can support the workability of the product, something like client feedback? We believe in taking the client to the site itself. We usually do this. We take the client to the site itself because we have a lot of trust in our technology. We are a 36-year-old manufacturing company. We didn't survive it just like that. We show them they can scratch the coating in a project such as Wave. We are there after 10 years and we see the coating still intact and looking better than other normal paints as well. I think that answers your question. Thank you, Mr. Geronimo. Then Taradhar asked, what is the impact on environment while application on sites? So depending on the site conditions, as I just said, so drying time can be affected. So your application time will increase. If the application in coastal areas, you can't apply water-based coatings there. And mostly the application time and the type of coating you are using is heavily dependent on the environment there. If it's humid, your water-based coatings won't survive and vermiculite won't survive. And only silicone epoxy will
My
survive.
question is, what is the impact on environment for water-based? These coatings are basically vermiculite coating is non-toxic. Water-based coating is also non-toxic. Silicone epoxy-based coating is they are having solvents. So little bit impact is there, but that you can compare with the normal paint which you are doing at home. So, but these coatings are lead-free, chromium-free, and not giving much impact to the environment. So they are safe to use. Even these epoxies, we can use it for food grade items also. Eddie, next question.
So can we use on a 1.5 mm thick GI sheet for switchgear enclosure And what will be the minimum thickness coating for 3 hour protection, and what will be the heat dissipation in the same?
At what temperature they want to use it, that depends. Means if it is for 300 to 400 micron, then 700 to 800 micron thickness will be good enough. If it is more, then they have to put the insulation over it.
Is this mandatory to have insulation on kitchen exhaust duct or MS duct with fire paint or with fire paint work?
Yes,
And this is mentioned in code.
yes, it is mentioned in course. For kitchen exhaust duct, you have to do it paint both side, inside as well as outside. And if you put the insulation, it will create a better fire resistance as well as insulation to the surface. Only that area, only that part which is exposing to fire, not all the kitchen area.
Mr. Naveen said 850 degrees Celsius for the 1.5 thick GI sheet for 3 hours.
Well, actually, for 3 hours, they have to go with the. They have to tell what temperature they want to.
850 degrees Celsius.
How much?
850.
850. Then they have to put insulation over it. Ceramic insulation will be the best solution. They can use coating as well as ceramic insulation over it. It will protect it from, and thickness of the ceramic insulation will be minimum for 3 hour, 100 thickness will be required.
I think that's all the question. Mr. Gijesh, I will reply you on mail. Thank you so much.
Yeah. With this, I think we have come to an end. So,
I think Geronimo Logo has asked on the normal chat, how can we ensure that the application is done as required on site? So if you are giving the job with material, you can make sure with the site engineer that the coatings are being done as per the application process shared before. Or if you are getting a material only job, the application is in your hand and you should follow the instructions given by the manufacturer in application process. And mainly there is only the preparation about the surface and the DFT check by alcometer and ensuring that correct amount of coating is being put in the correct space, and also no mixing in the coating. People usually mix a lot of water in the coatings to make it spread more and work, make it cheaper, but actually what it does is it loses the fire performance of the coating, and then the whole beam is exposed to fire. The water won't help. So I think these are the basic, but yes, follow the manufacturer's instruction very carefully or give the job with application. I think that's all questions. Thank you so much, everybody.
yeah. So, can we conclude, Aditya?
Yes, ma'am.
Yeah. Thank you, Aditya and Ashok Sibal sir, for your insightful thoughts. A big thank you to all the participants for joining and making this webinar very engaging and interactive. Looking forward to
Thank you so
meeting you
much,
all
everybody.
tomorrow at the Missing Link webinar at 11 a.m. Sorry?
Yeah. Thank you so much, everybody. It was really nice, creating more awareness about this fire safety. I'm new to this line, but still, I believe that, we are transforming, we are creating more structure steel buildings, we are creating more ducts. We should do the right type of coating on it. It's for longer lives, and it's about our building. It's India's building. It should look nice and clean. Thank you, everybody.